It is now my immense pleasure of welcoming someone who is very dear to us, Professor Mireille Hildebrandt. She's Professor of Interfacing Law and Technology at LSTS at the VUB and Radboud University in the Netherlands. Mireille is a legal philosopher, specializes in AI's impact on legal system, data protection, and the rule of law, and she's the editor of the Journal for Cross-Disciplinary Research in Computational Law, and again, someone very special to us. So the floor is yours.
Thank you very much. Before starting, I want to, like all the other speakers, say something about FARI. I'm a big, though sometimes critical, fan of FARI. First of all, because there are two universities collaborating, and anybody who knows the history of these two universities understands how special this is. On top of that, we're talking about different languages, which is of course part of that history. I've recently moved back from Brussels to the Netherlands, and one of the many things I miss is precisely this switch between languages. This is not only about two universities, but also about 10 different research groups. Of course, the AI labs and the engineers of both of the universities. But the interesting thing is that when you do good, interesting and important research, and you bring the output of that research into society, that output will change. And it will affect people. So it is extremely important that other disciplines at that moment, and we realize with AI before that, during the design phase, not only during the deployment phase, that the research into political science, social science, law and philosophy is core. Now, as you have noticed, your lunch break is gone. But I have good news for you, because if we apply artificial intelligence, the second part of this cartoon means I can just sit down, use your phone. I'll put the PowerPoint on and you will immediately know what this is about. So this cartoon is, like most cartoons, a joke. And we all know that there's nothing more terrible than somebody explaining a joke. So I'm not going to do that. But I hope by the end you understand what I meant with this. So I want to briefly say something about artificiality of AI and the artificiality of human intelligence. Usually people want to talk about the concept of intelligence. I'm going to talk about the concept of artificiality. Then I'm going to say something about the concept. So what is good, or a good, or the good? What is meant with public? What is meant with a or the public good? These terms are used in very different meanings, and that makes it very easy to agree, because we say public good is fantastic, and because you mean something entirely different than I do, we agree, but it's not very helpful. So it's important to address this. I have to then address the elephant in the room that I think we're all familiar with, but it has to be called out. Which elephant I mean, I will explain later. And then I will look into the, the design and the deployment of AI for the public good. So let's start with artificial intelligence. And I'm going to give you 3 snippets from 3 computer scientists who have some questions about AI. And here is Professor Dagmar Monet, computer scientist, who is citing somebody who says, what about generative AI? Well, ethics, most of the models were built on stolen data. Cognition, using it makes you more dependent and less smart. Environment, the energy costs are exponential. This is a very critical position. And I'm purposely citing computer scientists and not people like me, lawyers. It's a very interesting book by a computer scientist and philosopher Brian Cantwell-Smith, The Promise of Artificial Intelligence. He believes in artificial intelligence, and he even believes in general artificial intelligence, but this book is about why the road we are on now, with advanced machine learning, deep learning, reinforcement learning with human feedback, etc., is never going to achieve what we call intelligence. And he poses here reckoning, so counting, and judgment, which is something else. A more moderate position taken by Narayanan and Kapoor, two computer scientists from Princeton. Their book is just out. They've been writing and speaking about this for a long time. The book is called AI Snake Oil. They are not saying that AI is snake oil. They are calling out, making the distinction. When are we talking about PR and when is this genuine? And obviously, when we're talking about genuine computer science, producing this stuff, we're talking about very hard work. I had the privilege of having a chair here at VUB, but also a part-time chair at the computer science department of Radboud University. And I've been collaborating with computer scientists for 2 decades, actually. And that's always been party time for me. I've been teaching law to computer scientists, master's students, and even that has been party time. For instance, because they always try to get at least 5 or 10 steps ahead of me. They think she's a lawyer, you know. We can do this. So with pleasure, I watch them getting ahead of me 5 steps, and then I have to tell them, you are 5 steps in the wrong direction. Now you're 10 steps behind. So it's also a matter of learning about each other's discipline and why they are important. So the first point is that human intelligence is artificial by nature. And this is a law, a constitutive law of the human condition that was coined by the German philosopher Helmut Plessner. He's saying what is typical for us human is that we are capable of taking an eccentric position. And I have to tell you a little story to explain to you what I mean. If I have a daughter, Charlotte, who is, say, 1.5-year-old, and I tell, she's starting to speak, and I tell her, you are Charlotte and I am Mireille, then her answer will be, you are Charlotte, I am Mireille. And she's right, she's imitating. And then I tell her, no, I am Mireille and you are Charlotte. And she will say, yes, okay, you are Charlotte and I am Mireille. And it takes a couple of weeks for this human child to be reborn as a subject that minute that she realizes that she is me to herself and you to me. And this is the start of the eccentric position. So our subjectivity, our agency that is typical for language-using humans is born at that very moment when we are addressed by others. And from that me, you, we can also make the further step to the observer's position. So the he. Another very important philosopher, or actually a behaviorist, sociologist here is George Herbert Mead, who explained how this shapes our mind, our self, and society. And he used the example of a game of basketball, or whatever game is very popular in the United States, I forgot. And he says, if you are playing, you have to anticipate how others are going to act. You also have to anticipate how they anticipate you, otherwise you can't play. And this is not something you can consciously think about, because you will always be too late. This is becoming natural. But, he says, in a game like this, let's say with 22 people, I have to anticipate also how that person anticipates that person, how they anticipate that person, how that person, etc. All this is the right side of my brain, is figuring this out. And this is society, the anticipation of how we are anticipated. This is not something that computing systems do or can do at this moment. So the intelligence of AI models or AI systems is created by humans, and in that sense, it's artificial and not natural. This is an addendum, I assume you all know this. The term artificial intelligence was proposed by one of the founding fathers, McCarthy, at the 1956 Dartmouth Conference, which is often seen as the beginning of AI. And McCarthy actually proposed the term as a marketing term because they needed funding for one of their projects. So he said, let's call it artificial intelligence. And the others said, especially Herbert Simon, another founding father, he said, artificial intelligence, what is that? That's sheer nonsense. We should call it complex information processing. And then everybody said, sorry, Herbert, nobody is going to fund that complex information processing. Ugh. Okay, so they went for artificial intelligence, and that was, of course, good for the funding, we've seen that, but it has also raised all these metaphysical debates about artificial general intelligence, what is intelligence, and it has raised semi-religious and ideological debates about AI and expectations. So let's again emphasize, if we are talking about applying AI for the public good, that the achievement of AI are the achievements of human ingenuity. Now, we've talked about AI, let's talk about public good and public good. And let's start with, I see that the animation that I put into the slides is not really working, but that's because we're working with software. As anybody knows, there was a famous Dutch computer scientist, I think it was de Groot, but I'm not sure, who said, the minute you have written your first line of software and you turn around, the first bugs are there. That means that the costs of software, and this AI is of course also software, even if it's also hardware, are maintenance. Anyway, let's look at what is a good, and let's look at it from three different disciplinary perspectives. In ethical theory, a good is a moral quality, such as fairness, equality, justice, or freedom. And it's ethical theory, it's morality, so we're going to disagree about the ranking, about what fairness means. That's key to ethical theory, morality. We can disagree about it. It's important also that we can disagree. Then a good in economic theory. Economists want to count, they want to make graphs. For them, a good is an asset, tangible or intangible, private or public. For instance, a property, a trade secret, a claim, but also water, air, public road infrastructure. They are all assets. What I want to talk about is a good in the political democratic theory. And then a good is understood as a societal goal, such as justice, representation, economic welfare. And the interesting thing is that the perspective of ethics and economic theory are, of course, very important for political theory, but they should not be confused. There is a tendency, especially when you want to compute things, to move towards economic theory because it makes things calculable. What about public? Public has many different meanings, so it's very important to be aware what you're talking about. As in public administration, where it refers to the authority of the state, as in simply something is public or it's not public, as in publicly available, so think of open access and open source. Then again, public as in economic theory, public goods understood as non-arrivalness and non-exclusory goods, air, water, land, where the idea used to be that if I take some air, it's not that you have less air. I don't know if that's true in this hall, but generally speaking, it's true And of course, our climate change problems derive from the fact that this was an assumption that doesn't always fly. More interesting for this conference is public, as in political theory, referring to good or value that should be available for all, such as public health care, the right to privacy, or clean air. At the same time, in public theory, public also has a different meaning, referring to the public, which means the people. Okay, let's move on to the public good. You could say another term for that is the common good, as in what is good for everyone. But then, of course, the question is, who decides what is good for everyone? Is that the experts? Is that the people? What if they disagree? Let's say it's about a general interest, as opposed to one or more private interests. So mitigation of climate change is clearly a general interest. Making a profit on fossil fuels is a private interest. Now, there are many public and private interests. There's not one public interest, there are many. So you could say that the general interest, something that the government must follow or construct, means balancing between these various public and private interests. And that means that they have to distribute their government budget between, for instance, education, road infrastructure, etc., etc. You could say that digital transformation of public administration is very much a public good that is key to FARI. At the local level, not just high abstractions, but actually going and doing it. Ensuring fair, consistent, effective, and efficient decision making. Do we do that with automated decision making, or do we need human beings? And the answer is, of course, which mix? How do we get to do both? I think that AI for the public good, that you're talking about an asset or a goal that is good and should be available for all people. That is again the question, what do we mean with that? So let's talk about independent judiciary, electricity, water, education, clean air, many other things. Okay, now let's address the elephant in the room. Software. So the idea is that you don't read the last sentence and that I then read to you the first two sentences and that you then think about it and then I read to you the last sentence. Huh? So it's a famous saying when Gandhi was asked what he thought of British civilization. He was quiet for a minute. And then he said, that would be a good idea. And I had to think of that when I saw AI for the public good. That would be a good idea. But AI has an environmental problem. And of course you can use AI to solve that problem. We can emphasize that. But it's more complex than that. So this is the website I just showed you is part of the UN Environment Program. And it says there is an explosion of AI that requires data service, cloud infrastructure, that means water and electricity, and critical minerals and rare elements for the batteries. Now, if the prevention and mitigation of climate change is a public good, then we have to foresee new, because there's a lot of existing, but new geopolitical competition around, for instance, not just fossil fuels, but these critical minerals, because they're not in the same countries where the fossil fuels are, and there's a race now going on. All these activists worried about fossil fuels, they should direct their attention to this, because that is getting settled now, who gets hold of these minerals. And take, for instance, private companies investing in nuclear energy, which may jeopardize the public good. And my point here is not whether you are or I am against or for nuclear energy. That's not the point. The point is that it's private companies that are buying this, that are making decisions about this, that may have consequences for my children, your grandchildren, and our great-grandchildren, etc. So, can we assume that AI will offer effective tools to prevent or mitigate climate change and a sustained and reinforced geopolitical risk that we have here? This is a Financial Times, March, I think, of this year, basically saying, okay, we're always talking about these sovereign-sized big tech companies, but now let's talk about the AI cash burn by big tech that's already reached a sovereign-sized number. Let's talk about that. And then see that the return on investment is very unclear and questionable. But governments are just going on. They're pouring incredible amounts of money, look at the lower bottom of this slide, into this. But governments are not worried about return on investment, they're worried about getting re-elected. And that means you and me are going to pay for this if there is no return on investment. You're paying. So we have to be careful. And of course, everybody who's listening to me is thinking, yeah, but we have the Draghi report now, and there everything is solved. Or the direction for a new industrial policy for Europe has been provided. So I'm going to pick out some snippets and then leave it at that. Here, quoting, a wide gap in GDP, that's gross domestic product, has opened up between the EU and the US, resulting in foregone living standards. Basically, that means if we had the same increase in GDP as the United States, we would all be richer. That sounds to me like astrology. Then another very important point, real disposable income, that's something else than GDP. Real disposable income has grown almost twice as much in the US as in the EU since 2000. That's something to realize, though it's also part of astrology, as large parts of economic science are, I'm afraid. But the distribution of that income in Europe and in the United States tells a very different story, meaning that sovereign-sized big tech companies threaten democracy and the rule of law. And maybe half a year ago, people would say, ha ha, here you have one of these doom people. But I don't think I need to explain to you how at this very moment, as I am speaking, this is resulting in a government that serves private interests explicitly rather than the public good. So the public goods at EU level that are named as such in the report is three public goods. Breakthrough innovation that is needed as a public good to close the so-called innovation gap. 2, a Marshall Plan plus investment by private and public sources to enable decarbonization and competitiveness. 3, defense procurement and cross-border grids to increase security and reduce dependence. This is about the sovereignty of Europe. Note that these public goods are all part of a new European industry strategy. Now, I'm going to take a step back. A well-functioning market can, of course, be a public good. Can. Because it depends on what you mean with well-functioning. There are very many ideas about that. Independence, in terms of energy, from authoritarian regimes is a public good. But I can see people traveling to authoritarian Arab states to make a deal on putting cloud servers, because the cloud server is the condition of possibility for generative AI. So, what we really need, and to some extent have, but I think Europe is indeed on the right road here, but it's all not very easy, of course, is legislation. I'm not talking about regulation because that means very many things. I'm talking about legislation, democratic legitimacy, that enables reliable, robust, and resilient AI systems. That is a public good. Quoting again, the main reason EU productivity diverged from the US in the mid-1990s was Europe's failure to capitalize on the first digital revolution led by the internet, both in terms of generating new tech companies and diffusing digital tech into the economy. In fact, if we exclude the tech sector, EU productivity growth is about the same. Most of Silicon Valley business models are built on a European invention that was shared generously as a public good. Does anybody know what I'm talking about? Ah, that's very interesting. Here's a computer scientist speaking, right? Not really, okay. Well, it's actually this. The internet was, of course, shared generously as a public good, but the internet would mean absolutely nothing if we didn't have the World Wide Web, which was developed at CERN by Sir Berners-Lee. If any technology was a general purpose and generative technology, it was this, of course. And I find it actually rather sad that the so-called generative AI hype is hijacked, also in this report, by the logic of commercialization, extraction of added value, and thereby by the logic of scarcity, trade secret, productivity gains, and private interest. Now, I am not anti-capitalist. I'm not anti-market. Markets exist because of private law and public law. Without public law and without private law, contract and property, we have no markets. But it's important not to confuse economic models with the public good from the perspective of democracy. So it's a bit complex. I think the Draghi report is a very good report, very important report, but I think it gets some things wrong. And I think we need to reconsider the relation between private and public interest before giving into the assumption that private interests will serve the public good, which is, of course, the assumption of the Foundation for Economic Education, the Mont Pelerin Society, and all the economists that have been marinated in that. Now, I have -4 minutes, oh no, I still have 2 minutes, for the main dish. Designing and deploying AI for the public good. Again, the software is fooling me. So before you start making AI, ask question 0. Question 0 is, should we actually design and or deploy this? And for that I have 3 questions for you. And I'm not talking about cost benefit, because that comes after these questions are answered. Question 1, what problem will this technical solution solve? And I add to that, whose problem? Because very often, some people's problems are solved and new problems are created for other people. What and whose problems will it not solve? Yeah, some problems don't lend themselves to computational solutions, that's clear. So what we often see is technology pools. I have here a fantastic new thing that I want to do research on. So how do I get money? By saying that it solves this or that problem. Only that's not the problem that we are all worried about. But then computer scientists often tell me, yeah, but Mireille, that problem we can't solve. You understand that. And we have this now, so let's go for it. Is that wrong? No, not if we're talking about science, because science is about exploration. And a lot of things we don't know in advance. But if somebody's trying to sell you something, then these are the questions you must ask. So, what and whose problem is solved, what and whose problems are not solved, and what problems are created. So what we must learn is to distinguish not between fundamental and applied science, that's a bit old-fashioned, but between science, scientific inquiry, research within the contours of the university, where freedom and exploration are important. And that is done by scientists. And the minute that the output enters civil society, and then we need citizens because they are going to affect it, and then we need democracy. I'm going to rush through this because I know we are, the main dish has to be eaten very quickly, sorry about that. But you do have AI, so there are ways to digest this quickly. So we all know about the issue of bias, lots have been written about it. Let's say that I only want to talk about the issue of proxies. If you want to make the public good computable, you will have to disambiguate it. And you will have to make certain assumptions about what proxy you have for that public good. Training data code, labels, the target variable. Yes, the present is coming now. I really have to shut up. Now, if you really want to go into the nitty-gritty of making sure that, for instance, we distinguish between the accuracy of a model within the controlled situation of the model building and the reliability in real world, we will need participatory slow science and slow development. And in the end, we will be much faster than the cheap way of trying to break things and take a lot of risk, always with other people's life and assets. So let's take it slowly and be faster. Thank you.
Thank you very much, Mireille. And now is probably the awkward moment, but we wanted to thank you for all these years with us and also at the VUB. And we wanted to just give you a special homage as it's our last year with us. But it's juste un au revoir. So thank you very much.